All right, here we are. This is your lesson from page 135, and we made it to the end of chapter 2. This is the last chapter, or the last lesson in chapter 2, so that's exciting. Your objective today is how to compare mathematical expressions with real numbers. So your summary will talk about how do you classify a number. How do you know when it's a whole number, an integer, a rational number, all three? And how do you make that classification? That's what your summary should be about today. So starting right in, an irrational number is any number that cannot be expressed as a ratio, such as a over b. It's a decimal that doesn't end. So for example, like pi. Pi is a decimal that never ends, but it also doesn't repeat. So if it's a repeating decimal, as here you see the bar over 0.4, that tells you it's the same as 0.44444 repeating forever. Then it's not irrational. Then it's actually rational. And it's any square root of a non-perfect square. So for example, the square root of 36 is a perfect square, so it's rational, but the square root of 9, well, that wasn't a good example. The square root of 11 is irrational because it's not a perfect square. You just know that right away. So I would definitely highlight the parts in red in your notes. And then here it repeats. Irrational number is a decimal. It does not repeat or does not end. Okay? Then real numbers are the set of rational and real numbers together. So I just truthfully copied this from the book, but I do want it in your notes, but I want you to listen first. So you know a whole number would be 4, 100, 2,000, 500,000 is a whole number. A number that's an integer would include the negative numbers and the whole numbers. A rational number, if it's rational, you can also call it an integer and a whole number. But a rational number can be a fraction, it can be a percentage, it can be a decimal, it's a perfect square, or even a negative fraction or a repeating decimal. So here your book is going to ask you to classify. We see right away that this is a repeating decimal. So because it repeats, you know it's rational. This one you know is a perfect square, so the answer is 6. And because the answer is a whole number, it's also a whole number and integer and rational. Here we go. This is our first example of one that is not a perfect square. And so because it's not a perfect square, you know right away it's irrational. And if you did figure it out on the calculator, you would see that the decimal does not end and it doesn't repeat. So it's irrational. All right, again, you see this example right away is not a perfect square. So you know again, it's a decimal that doesn't end and it doesn't repeat. This you can recognize from our chart on the first slide, is a rational number because it has a fraction, and that makes it a rational number. The square root of 100 is 10, and 10 is a whole number and an integer and rational. All right, your book will also ask you to compare the numbers using less than, greater than, or equal to. Go ahead right away and find the square root of 7 on your calculator, or you can use the internet and they have square root calculators. When I did it, I found it was a not repeating decimal, but it didn't end, and a little over 2.5, compared to 2 2/3 has that repeating 6. So because there's a 6 in both tenths place, you have to move to the 100th place or the 100th place and compare a 6 compared to a 4. Well, 4 in the hundredths place is less than a 6 in the hundredths place, so you would use the less than sign. A few more examples. Excuse me. The bar above the 5 means it's a repeating decimal. So one with a repeating 5 in the decimal place. Here, using the calculator, the square root of 2 and 25 hundredths is 1 5/10. And because we know the next number after this would be a 0, you're comparing a 0 to a 5, and you would say this number is less. So you would use the greater than sign to show that the number on the left is greater because of that 5 in the hundredths place compared to a 0 in the hundredths place. Our next example, remember if you're given a percent, you need to move it 2 decimal places to the left. So you would have 157 thousandths compared to, use the calculator, find the square root of 2 hundredths, and you get 141 thousandths. So there's a 1 in both tenths place. So then compare the 5 to the 4, and the 4 is less, so you know you would use the greater than sign. All right, here, comparing the square root of 11, use the calculator, find the square root. It too is a decimal that doesn't repeat and doesn't end, compared to 3 1/3 with, whoops, there, I just kind of showed it. We have a few glitches here. Let me move it one more time. And you can see, because this one has a 1 in the hundredths place compared to a 3 in the hundredths place, this one is greater, so you would use the less than sign. Alrighty. 625, we already know is a perfect square, but when you put the decimal there, it's the same as 2 5/10. Here, we would move the decimal 2 places to the left, like we do for any percent, and we would get 2 5/10 again. They're equal. All right, last slide. So ordering from the least to the greatest, you can look on your calculator to find the square root of 60, and then I'll show you the rest. But keep in mind when they're negative numbers, the least actually looks bigger, and the greatest, because it's negative, looks like a smaller absolute value. But we'll get to that together. All right, so the square root of negative 6, or the negative square root of 60 is -7 and a long decimal place, but I highlighted the 4 because that's the part we'll actually compare in a minute. -7, we can just keep that. Here we go. Negative, just going to be a little glitchy today, huh? There we go. Sorry about that. There we go. So -7.7, but I put the 0 there because we're going to compare the 4 in just a minute to the 0. And the last one, you'd take your calculator and divide. 66 divided by 9, and you would get -7.333 repeating. And so notice we're comparing the 4. Well, actually, let me move this so you see it. It's just easier that way. Whoops. All right, so we're comparing, if we put this on the number line, -7 is actually the greatest. And then because there's a 3 in the tenths place, that's actually the next greatest, remember, because of the negative sign. Then -7.0 would come first, because -7.74 would come be your least. Even though it looks like the greatest, because of that negative sign, it's actually further away from 0. All right, if that's a little bit confusing, we'll do another example together in class. Great job taking notes.